To make 4 short videos of the neurotransmitter glutamate and disease called epilepsy, which is related to glutamate. The first one is, what does glutamate do? Glutamate is an excitatory neurotransmitter in the central nervous system, which plays an important role in neuronal activities. Glutamate is transferred from a thing called glutamine by the effect of the enzyme named glutaminase. Now, how does glutamate work inside the neuron? An action potential arrives at the end of the presynaptic neuron. It makes it depolarized. When it is depolarized, calcium ion channels opens up, making calcium ion flow inside the neuron. Then this makes it positive. Then when it is very positive, the chemical vesicles that contain glutamate binds outside part of the neuron and releases it by a process called exocytosis. Then the released glutamate binds to the receptors on the postsynaptic neuron like this, and there are 2 types of the receptors called NMDA and AMPA. Now, when this bonds to the receptors, sodium ion here rushes inside the neuron, making new action potential on the postsynaptic neuron. Thank you. These are the images of firing neurons. It looks great, but what if this happens too much? So, for episode 2, we will talk about how we stop glutamate to overly activate the neurons. After the process of episode 1 is over, we have to terminate the whole process. Now, how do we do this? Glutamate don't just disappear or get completely broken down. We can reuse them through specific processes. First, they are reuptaked inside the neurons. They go back inside like this. Now, after this happens, they are turned back to glutamine. Then why do we need this process of terminating it? Of course, glutamate is a crucial part of our body, but when it is too much, it leads to overly activating neurons. And when overly activated neurons happen, brain cells get damaged. And this could lead to diseases like dementia or something else. Thank you. Now, this is a picture of a person lying down on the floor with seizures. When seizures happen repeatedly in our body, we call it epilepsy. Now, every problem starts with abnormal firing of the neurons. In case of epilepsy, too much glutamate or too much activation of the receptors of glutamate is the problem. The whole process goes like this. Now, lots of glutamate is released. Now, the receptors, AMPA or NMDA, gets overly activated. Then, too much sodium ions or calcium ions, which is inside the neuron. Then action potentials keep happening. Then the seizure spreads to the nearby neurons, leading to epilepsy. Now, The next will be how we treat epilepsy by using drugs. Thank you. In the previous episode, we talked about how epilepsy happens. So in episode 4, we will talk about how we treat this. Now in summary, when we have a problem, we can think of 2 solutions. Inhibit the cause of the problem or activate something that can do the opposite thing. This leads to antagonists and agonists. Antagonist is a substance that binds to the receptor but does not activate it. So the original substance, like glutamate, gets blocked. These mostly work by inhibiting the activation of the receptors. In case of agonists, they are things that bind to the receptors and make the same effect. So the effect increases. So to use this as a drug for epilepsy, you can use agonists to activate the GABA receptors that works the opposite as glutamate. This is a PPT slide I made for the class. It shows drugs for epilepsy that work in different procedures, like decreasing excitatory factors or increasing the inhibitory factors. With these drugs, we can relieve the symptoms of epilepsy and make patients better. Thank you.